So the very first topic of class 11 that we are going to discuss is units and dimensions. And broadly speaking, this chapter of units and dimension has been divided into three main topics, and that's units and dimensions, a basic discussion on that, significant figures, and error analysis. So without further ado, we'll be basically starting off with the discussion. And the very first topic is the fundamental units that we have. Now, in SI system, that's an international standard of giving units, we basically have got 7 fundamental quantity, and that is length, mass, time, electric current, thermodynamic temperature, amount of substance, and luminous intensity. Now these are the fundamental units, and we can actually construct a derived unit comprised of all these fundamental units. But let's start from the simplest: length, mass, and time. And as we all know, in the SI system, it's meter, kilogram, and second. Please take a note that if you are considering any other system, which I will discuss in the next slide, let's say CGS, the unit won't be meter but it would be centimeters, it won't be kilogram but it will be gram, and the unit of time will remain as second. The symbols are pretty much familiar with you because you have already learned that in your lower classes: m, kg, and seconds. Now moving further, we have got 4 more fundamental quantity. These are electric current, the unit is ampere and denoted by capital A; thermodynamic temperature, the unit is Kelvin and denoted by K. Please take a note that in general, when we talk about temperature, we have this habit of using centigrade as the unit, but when we are considering an SI system, Kelvin is the standard unit. One more point would be it's denoted by capital K without any degree symbol, so please take a note of that. The amount of substance, which is mostly used in chemistry, has a unit of mole and it's written as MOL. We'll see that these symbols also has got some importance later in this chapter. And finally, luminous intensity, the unit is candela and denoted by CD. The intensity, you know, if a light is bright, the value of candela would be more. In case it's less, it will be less. Apart from these 7 fundamental units, we have got 2 more supplementary units, which are the plane angle and the solid angle. So you must have all heard about the unit radian. That's a unit of plane angle, and in case we are talking about a solid angle, the unit is steradian. So if you are having 2 lines making an angle with each other, that's measured in radian. On the other hand, if you're basically considering a cone, you can consider an ice cream cone that you hold, that the angle or the solid angle that is made at the bottom is usually considered in units of steradian. The 2 other systems are CGS system. C here stands for centimeter, G stands for gram, and S stands for second. So if you consider a CGS system, the unit of all the quantities usually change. For example, let's say force. Most of you know that the unit of force is Newton, but that's in SI system of units. But when we are considering a CGS system, the unit is dyne. For that of work or energy, the SI unit is joule, but the CGS system, the unit is erg. Another system which is not that much reputed and not used that much is FPS system. And this system, the unit of length is foot, the unit of mass is pound, and unit of time remains as second. And this system, we have the unit of force as poundal. Please take a note that force is a derived unit, has a derived unit, and it's not a fundamental unit. So if you consider something like centimeter, gram, second, meter, kilogram, or second, these all are fundamental units, but at the same time if you say dine or erg, these are derived units. That means these are derived by a combination of two or more fundamental units. Well, these powers might be something familiar to you. When we're talking about power of 6, we're talking about mega, and is usually written as capital M. When it's power of 3, it's kilo and it's K. Power of 10, I mean, let's say we're considering 1000 gram, it can be written as 10 to the power 3 grams. So simply we can say it's 1 kilogram. If we go to the lower units, we have got 10 to the power minus 2, that's centimeter, centi. So we basically call it a centi, and from there we get the term centimeter. So we have got the symbol as C. If it's minus 3, we get as milli, minus 6, micro, minus 9, nano, and minus 12, pico. Kindly remember these symbols, because if you write down something as capital M and let's say ohm, it will be mega ohm, but if you write down small m and ohm, it will be milli ohm. Let's come to the basic definition of dimensions. Now we have the physical quantities, and if we can represent them in terms of powers of the fundamental quantity, that will actually represent that physical quantity. Well, the definition seems to be slightly complicated, so let's take an example to understand this. Let's say, for example, density. Now all of us know that density is mass by volume. Mass is fundamental, but volume is not the fundamental part. So we can convert this volume into length cubed. As we know, if you consider the volume of a cube, it's length cube. And if we consider any other shape, let's say for example a sphere, it has something to do with the radius cubed, the volume. So we have a cube of a quantity which has a measurement of length. So it's mass divided by length cubed, or we can say mass length to the power minus 3. So in that way we can represent mass as capital M, length as capital L, and then we can say that the dimension of density is ml to the power minus 3. Please take a note that the dimensions are always represented without square brackets, and you can't use any comma as such. So please take care of that, else you might be losing marks. So these are the three quantities which is more easy to remember, but what about the other quantities? Let's say for example electric current, that is denoted by A. Thermodynamic temperature is denoted by K. Amount of substance is written as MOL. Yeah, that's right, you write MOL within that square bracket, and candela is represented as CD. Also take a note that quantities such as any numerical value, let's say 5, or let's say pi, the value is 3.14, or any other trigonometrical function, say, let's say sine theta or cos theta, has no units or dimensions. So in case you have an equation, there is no way to know that whether it has got some values like 5, pi, or any trigonometric values. So in case you have understood this, this should not be very difficult. So velocity will have a derived unit, because it's a combination of two fundamental units, that is meter for distance and for, we can say in general, length, and times second. So if we define velocity, it's displacement by time. Displacement has got a unit of meter, time has got a unit of second, so it's meter per second. So how do we write it down as a dimensional formula? The unit of the dimension of meter is L. The dimension of time is t, but t is at the denominator, so I raise it to power of minus 1. So I can simply write it down as lt minus 1 within the square bracket. However, I can also change it, and I can also write down mlt all three together, and m will have a power of 0 because there is no mass involved. Similarly, if we consider other quantities like acceleration, which is velocity divided by time. Now velocity is nothing but displacement by time, so the final expression in terms of the fundamental quantities is displacement divided by time square, so that's meter per second square, and we have the respective dimensional formula. Similarly, you can find out the dimensions of all the other quantities, which should not be very difficult. A very important note to be taken here is that if you consider two quantities, let's say work and energy, now both of them has got the unit as joule. So in case the SI unit is same, then the dimensional formula will also be same. So please take a note of that, because in case you know two quantities having the same units, the dimension must be same. And that's basically a thumb rule that you should always remember to do your calculations and answers faster. So we basically have this equation, and we are also going to discuss more about dimension in our next class. Thank you.